Hi Andre, this is Emmeline here for the final sprint. Just a few things I want to note before we get started. There is no sound in this whole thing. There's no high score tracking or entering, and there is no letter collision. So with that in mind, I'm going to be doing this in parts. This will be the first part, which will be gameplay. Right now we're in tractor mode. I'm pretty much just going to go through the list of things to bring up that you gave us. So let's go ahead and get started in one player mode. So I'm just going to press a 1 on my keyboard, and there we go. So here's the blaster. Right now I'm moving it using the keyboard. You can see it collide with mushrooms there, and then you can see it slide off. Here's this, let's do the bullet first. So there's only one on screen. I'm holding down the bullet. You can see when the previous one dies, this one is able to be used. For mushrooms, they have 4 lives, or 4 animations. The centipede, once again, no sounds, but you can see it turn. I'm going to go ahead and kill this one so we can get onto other waves. But you see the one on the right there just ignored those mushrooms when it turned. Here, let's look at this spider. It got a 600 there. Early in the video, you could see it be a 300. If I can get one super close, there's a 900. So now the centipede's moving a lot faster. You can see a flea on the screen dropping mushrooms, and you can see the one rogue head, which is moving faster than the body. Let me shoot this flea, or not. There you can see it move a lot faster. And die. So let me kill this centipede, hopefully, so we can get on to the next thing. Let's see if I can get 900 on this. Oh, there was still a 600. It has to be really close to a 900. And you can see the centipede's bouncing right now on the bottom. I have a scorpion on the next wave, and everything generally gets a little faster. Okay, and let's just kill this one last head. We can see this last wave. I never promised to be any good at this game, now did I? Okay, there we go. So this is the last one. You can see there are 2 rogue heads, and scorpion should start spawning as well across the screen. There goes a scorpion to the right. Let's see if we can get a scorpion to the left. There is one to the left, and it poisons mushrooms along the way. Hopefully the centipede will hit this poison mushroom. If not, let me go ahead and die so we can get one that does. So there you can see the mushroom field regenerate from bottom to top. Oh, and there a flea goes fast because I hit it. And here's the centipede hitting the thing, and then as you see it stops when it gets to the bottom row. Okay, so let me go ahead and die a couple more times and I can show you 2-player mode. And there's the field regeneration once again. Let me just get one more. Okay, so here's back to the tractor mode. I'm not touching the keyboard right now. The blaster is moving on its own, and that is through, and that is through just a timer, or it's not a timer, I'll show you that code eventually, but it's just, once every 5 frames it changes directions. I'll go ahead and press the 2 now to show you this 2-player mode. So now in player 1, you can see at the right, the player 1 score is changing. I'm going to get to the next wave, so you can see that waves are maintained through death and such. Okay, here, now let me go ahead and die. So let's keep track of one mushroom on the screen, or cluster them, so you can see when I die and come back, the mushrooms stay the same. So here I am, player 1 again. You can see the scores and lives updating at the top of the screen. Yep. Also, something I'm not sure I pointed out the first time, was the spider does get faster during the 3rd wave, so I do have control of the spider speed. Okay, now let me die again. So we're back here. If you kept track before, the mushrooms are the same as they were on the first one. Let me go back to show you and here we're back to this wave again as player 1. And if I die here, I get to go back to player 2 one more time, still on the first wave. And then if I die, we go back to a tractor mode. And then you can go back into first player if you want again and play another game. Yeah, so I think that's all for that there. Hi Andre, this is part 2 of the video. This will cover the different patterns. We're going to start out with the strategy pattern. So here you see the random controller and the keyboard controller, which are both derived from the ship controller class. So here let's look at the ship controller class. See, it has the move and the fire functions and nothing in the CPP file. So then derived from that, we have this random controller class, which you see the fire method, which is constantly firing when it's random, and then the move method, which calls back to the ship, and then every count it randomizes which direction it will move. And then we have the keyboard controller right here. So it asks keyboard, is it pressed? And then calls back to the ship's move functions. Like the random controller does. And then if we go over here, you can see that we only have 2 of these. They're created when the program is run, and then we never create another one of these controllers. So if we look in where they're called, you can see right here it is passed to the player which kind of controller it's using when the players are created. So there's that, and there's that. And then if we look in the ship in its update function, it just right here, it just calls, it gets the player, it gets what kind of control system the player is using, and then it calls that's move function. These are just to clamp the move to the player area, and then it does the exact same thing to the fire. So for the fire function, so it gets the player, it gets the controller, and then uses the fire function. So that's all for the strategy pattern. So now for the observer pattern. I think one of the best examples of this is in the critter factories. So when a critter is created, in this example of flea, it is added to an alive list. You see up here it's created and add to alive. And then when it's destroyed, you'll remove it from the alive list. And then whenever the spawn controller, which controls all the spawns of the critters, gets a notification, hey, the ship died, it will call this kill all function. So all things that are observing at that point will be destroyed. So the fleet's not constantly checking, is the ship alive? Is the ship alive? The ship notifies it when it has died. You can also see this as an example, generally if we look at it broader, whenever the ship dies, it calls the game manager that the ship has died, and the ship manager updates right here in the ship death thing, everything that needs to know that the ship has died and all the functions that go with that. Hi Andre, so this is for the simple factory pattern. So what just happens, I started up the game, and now a flea is about to be spawned. I'm going to use the flea as an example for how the specific functions work, and then show you that all the factories delete themselves. So the first flea is about to be spawned, so it does the check. And then there isn't a flea already in the pile, so it creates a new flea. Yep, and it adds it to an alive list, so it can be deleted when the ship dies. And then we can continue on with the game. So here it goes. We watch the flea fall to the bottom of the screen, and then the flea is going to be recycled. So you remove it from the alive, and then you add it to the pile. And so then when the new flea wants to respawn, it asks again, is the flea pile empty? And this time it's not empty. So now if I exit out of this game, you can see the flea factory gets terminated. The scorpion factory, the spider factory, the ship calls that the bullet factory is terminated. The centipede heads are terminated along with the centipede bodies. So that's all the factories being terminated. And then another thing of note when it comes to simple factories, they're all singletons. They all of their declaration files look pretty much just like this, with all the public ones being static and referencing private ones to like create the fleas and recycle the fleas or whatever critter it is. And also my ship does not have a factory. If we come over here and look at my ship real quick, it's because there's only ever one ship on screen. So the way it works is whenever something happens to it, which causes ship death, like it collides with the centipede or the flea, you reset the position. So that function basically just resets the position back to where it starts. And that's all for simple factory. Hi, Andre. This is for the singleton pattern. You can see my game running right here. Oops. What I'm going to do is I'm going to exit this game. This is a list of all my singletons right now. I'm going to show you that they're all terminated and then show you the declaration of the classes to show you that those are all correct too. So let's go ahead and click escape. And here you can see our first breakpoint in flea factory, the delete and the set to null. Not a static class. Here you can see the instance being declared, and all the public methods are static. So then the flea pile is a singleton. So if we look at that, same thing, not a static method, the instance, and all the public ones are static. The scorpion factory, same thing, not a static method, all the public ones are static. The scorpion pile, not a static class, all the public ones are static. The spider factory, and then while that loads, we can also see the spider pile as well. Yep, spider pile. Then there's the critter death pile. Same thing, not static. The instance, all public ones are static. The critter death factory. Not static. All the public ones are static. The bullet factory. Not static. All the public ones are static. The bullet pile. Not static. All the public ones are static. And now we get into the managers. So there's the score manager. You can see it's not static. All the public things are static. And there's the terminator was called. The game manager, the delete and the null pointer, as you've seen. Not a static class, and all the public, these are all the public ones up top in this one. All public, and down here, the instance is called. Then the centipede factory. There's a factory for the heads and for the bodies. The centipede factory is for the heads. Here's all this, and all the public ones are static. There's a centipede pile. There's the centipede body factory. And the centipede body pile. You can see the same thing here. All the static one, all the public ones are static. The player manager is deleted. not a static class. All these private, and all the public classes are static. Here's the ship manager. You can see the same thing, static on all of these, not a static class. And then I think we only have 2 left, so here's the grid manager. The same thing with the instance, not a static class, and then all the public ones are static classes. And then I think the wave manager should be our last one here. Oh, still the mushroom factory. Sorry, this has been a bit more of a tedious video, but I know you wanted to see that they were all implemented correctly. Same with the static classes. Mushroom pile. Not a static class. All the public ones are static. And then wave man. There we go. Not a static class. And all the public ones are static. That's something I'll just note now. I didn't know how to delete something just when the game is exited. I only knew how to delete things when the end of the scene was called. So my waveman, all the data is deleted and reloaded at the beginning of every scene, not just at the beginning of the game. Because if I just left at the beginning of the game, that would be a memory leak of pretty much the entire file at the end, or the entire structure of all the saved wave data, because I wasn't sure how to delete that. And that's all of them. So that's it for the singleton pattern. Hi Andre, so this is for a command pattern now. Since I don't have any sound implemented in my score systems, I only command pattern, so we're going to be looking at that. First of all, this is the base class, which is command score. From that, I only have one derived class. I just use command value. So for ones like the distance one for spider, the distance and which command to send is decided on the spider side. So here we have the command score value. This is the header class. This is the body class. And then we have the score manager. So it asks which score is this, it queues them, and then at the end of the frame, the game controller calls to process the scores and delete them. I don't have a factory or a pull for those, so a new command score is created for every score command. And now let's take a look at how this is implemented in the flea, and this is how it's implemented in all the critters or anything that sends a score. So when the flea is created, it is given the pointer to which command to use, and then when the flea dies from the player killing it, so when a bullet kills it, and not when it's just regularly destroyed, it will call the event simulator, which then sends the score back to the score manager, which then queues that particular score, and then once a frame, it will process all those scores. And then if we look at the spider real quick, I'll show you how the distance one is done. So here it's given a near death, a medium death, and a far death, 3 different ones. And so when it is killed by the bullet, we go to the spider death, which is its own class, and it asks how far away, what distance was the ship position from the position it was passed. And then it decides which one to send to the score manager to process at the end of the frame. So that's all for the command pattern. So this is the final pattern, the finite state machine, or the state pattern. I have this implemented for my centipede as well as for my spider. So let's go ahead and look at the centipede one. This is the centipede's update. So it takes everything it needs from the current state. So the frame, the scale, and that's pretty much all. And then my centipede does all the updates for the things behind it. and then it checks if it needs to get the next state. And then also my speed for my centipede, I'll just address it while we're here, is controlled by a for loop in my update. I wish this wasn't the case, but I didn't have time to change it. I'd rather do it by different speeds inside of the positions or something of that sort. But I thought I'd address it while we were here. So let's move on to look at the finite state machine. So here everything is just declared once. These are static if we look at the header file. These are all public static consts. So then if we look into the actual state machine, this is the base class that they're all derived from. It has a few base functions that they all take, which is the ability to get the things that the centipede update will need. So then if we actually look at, and they also have a few shared variables. So this is move left and down. If we looked at the header file, it is derived from the centipede move state. And if we looked at the actual thing, it does all the tests that will be needed specifically in this state. So checking if anything's left of it, checking if it does need to turn if it's at the bottom row and needs to switch going up, and then checking if it is poisoned or if it's just a simple blocked or non-poisoned mushroom. So you see then would turn, it would change to a different state, and that state, all those states have similar tests just to this one. So then if we take the time to look at a poison one, then it's just checking, do I need to keep going down or am I at the bottom now? Because the poison one snakes straight down to the bottom. I think that is it for the finite state machine. Hi Andre, this video is over the explosions, the blaster, and the bullets. So starting with the explosions, you can see you've already seen my critter death factory pool and the critter death class. I also have a spider death class and a ship death class, which is down here. My ship death class and my spider death class don't have factories. I just never got around to it. They both mark themselves for the story when they're completed, but they aren't recycled. That's about all for the deaths. Moving on to my blaster. So here I have the ship. Let's take a look at the update call. The update call, so the controls are actually stored in the player. So it asks the player manager, what player do we have and what are those players' controls? You can see the player stores its own controls. And when the player manager is created, it tells you that the attractor, which is player 0, has random controllers, and player 1 and player 2 has the WASD controllers. So then that knows what controllers to use for the ship, and the ship calls those controllers. You can see there are no if statements in here or anything. There was one if statement inside the fire function, which asks whether or not it can actually fire. And then the last thing for this video, let's go ahead and look at the bullet update call, which is right here. You can see there's only 4 lines of code. It updates the position, and if it's off the screen, it marks for destroy. And down here, when it's destroyed, it tells the ship that it can fire again. Hi Andre, this video was just over the centipede, and things relating to that. So this is, just start off, this is the movement collection. It's only created once. Its header class is static constant. So this is the one that they all use. It's just like this for the scale collections and for the frame collections, which frame it's using. So then also let's now look at the parent class. This is the parent for centipede body and centipede head. If we look at the header part, you can see there are a lot of functions that these two share. Not all of them are declared here because not all of them are exactly the same in the body. But all of them are declared here. If we look at the actual file for centipede part, you can see that like the set ahead, the set behind, the collision with the bullet, the collision with the ship, the draw function, the event stimulator, they're all shared right here. So that's code taken out of the centipede body and centipede head and put here instead. If we look at the actual update of the centipede head, you can see that it takes everything from the state it's in, no if statements there. The only if statements it does is to check that there's something behind it. If there is something behind it, it updates that. And then going from there, the body that's behind it has nothing in the actual update. It only has stuff in the do update, which is down here, which this is what the head calls. And then it calls the one for the one behind it. and that is all the same stuff. They update the scale, the frame, the position, all that. And then it also checks if it needs to update the state. So every 8 frames or every 8 movements, it updates the state. Andre, this video is over mushrooms. So first, a brief overview of how my mushroom and the mushroom field and grid is controlled. I have 3 classes pretty much. So I have the actual mushroom, I have the mushroom grid, and then I have the grid manager. Starting with the big picture, what the grid manager does pretty much is does things like it can return a random row, a random column, and it will take a pixel position and return a grid position. It also is pretty much the interface for everyone else to interface with the grid. So if you want to tell the grid that the ship died, you tell the grid manager, and the grid manager will call the appropriate function in the ship or in the mushroom grid. Or if you want to tell it to destroy itself and save, say when a player dies in 2-player mode, you tell the grid manager that, the grid manager calls the appropriate function in mushroom grid. So it's pretty much an interface, a go in between, and it can also be a singleton because my mushroom grid is a game object simply so it can have the alarm to regen the mushrooms. So that's really the only game object class or function it uses. So now getting into more specifics, let's first look at the mushroom. You saw the mushroom factory earlier, but there's a mushroom factory in a mushroom pool. Here you see the regen for the mushroom. It resets the frame, it checks if it was poisoned, so it resets the frame correctly, it resets the health, and it plays the critter death. That's just the mushroom regen. The implementation, as you can see here, of poison is just setting a true or false variable and switching which frame it is. There's no separate class or anything like that. Now for the mushroom field, or the mushroom grid as I call it, let's take a closer look at that. So here's my mushroom grid class. It has a mush array, which is just an array of mushroom pointers. There's slots for every slot in the entire screen. There's a function to destroy mushrooms. There's a function to create mushrooms. There's a function to create mushrooms if you're giving it a grid location, and a function to create mushrooms if you're giving it a pixel location, just for different uses. There's the regen mushroom, which we'll get into in a second. And then this is also where you call to look ahead left or look ahead right for the centipede. And then here's the function when you want to destroy the grid in 2-player mode and save it. So all that's done is it goes through the entire array, looks at everyone. If it's not an old pointer, that means there's a mushroom there, and it passes that to the player has an object called current grid, where it saves an array of booleans. And so when we do the load grid, it goes through the array of booleans and it asks, is this true? If so, we create a mushroom there. If it's false, we don't create a mushroom there. Now let's look at the regeneration. So what it does is, if it gets the message from the grid manager saying, hey, it's time to regenerate, it activates the alarm. And so what the alarm does is, it's right here, is it says this is true, and while this is true, we're gonna go through the mushroom array pretty much, starting at the beginning, going to the end, or starting at the bottom and going to the top. And you're going to check, is each mushroom healthy or is it poisoned? If either of these things is not true, you're going to call the regen class, and then we reset the alarm for just like a 1/10 of a second, just enough for the animation to play and to move on to the next one. So then it exits out of all of this and then comes back. And then if you're at the end of the list here, it does this if check. If you're at the end of the list, test is set to false, and you exit the loop. On the topic of accessing into lists and such being efficient, here you can see in the regen You only go through the list once. You check every mushroom run, so that's as quick as it can be. For creating and killing mushrooms, you aren't going through the whole list. When you create a mushroom, you just can index into the exact spot where the mushroom is just by converting the grid location to a point in the array. Yeah, so here you can see that mushroom create. You're basically just setting it, like here you create the mushroom through the factory at this position. You just hand it the position and it creates a mushroom in that slot, so no indexing, no going through the list, just saying, right, here's where I want the mushroom. And it's the same when you kill a mushroom, you just set that exact slot to a null pointer and delete the mushroom, or pass it to the pool. I think that's all for the mushrooms. Andre, this video is going to cover the scorpion, flea, spider, and the controller that spawns all of them. So first thing about the scorpion, the only really thing I have to say here is that it does use collision to make mushrooms poisoned. I just didn't have time to change that after my initial implementation. So that's really the only thing I have to say here. It checks on initialization, it checks which way it's going to go, it scales accordingly. Nothing really else to get into here. Then for the flea, it asks when it's created, it asks for a random position, and that's where it is created. And then here you can see once every 8 spaces or once every low cube, it checks to see there's a random chance of 1 in 6 it will spawn a mushroom in any given place. And that 6 can be changed to make the frequency more or less. And then for the spider, it uses a finite state machine. It spawns within a range in the player zone and then just moves up and down across the screen. You've seen that already through the demonstration in the first video. Yeah, there's nothing really else to say there. Most of the stuff in this video is in the spawn controller. So it has variables for everything that needs to be changed, whether or not the scorpion or the critters need to be spawned, how quick they move, how often they are spawned. The only thing that isn't here is the flea or the mushroom grid is in charge of how many mushrooms it takes for the flea to spawn. That is inside the mushroom grid, not in the spawn controller, because the mushroom grid needs to know that number so it can tell the spawn controller to spawn a flea at the correct time. So if we look in here, the reason I have these all in one class is because pretty much they all just need one simple thing, like allow like the you to set all the times and stuff. It just needs a spawn flea, a spawn scorpion, a spawn spider, and then all the stuff like destroying these and making sure that we're keeping track of the live fleas so we can kill them when the ship gets killed. That's all taken care of in like the flea factory or the scorpion factory. We saw this in our earlier video where we added to a live so it can be destroyed when the ship dies. So I didn't think this was enough material to be split up into 3 different controllers when it seemed to be doing just fine in one. Hi Andre, this video is over the wave data, wave manager, and the wave file. So let's start by looking at the file that you can write into. So all you have to do is write wave space the number you want, and then there are a series of variables you can do, like spider allowed, yes, spider speed, you can just write numbers, flea allowed, yes, and then spider time between spawns, that's in seconds. These can be all capital, all lowercase, really whatever you want, and then you can also change which color palette it is. The waves can be in any order, and it keeps reading the same wave until you enter wave, the word wave, and then another number. Yep. So you can all see there's mushroom number to spawn flea, centipede body speed, centipede rogue head count, rogue head speed, body count, everything you need to edit right there. So let's look at the actual wave manager now. I brought this up in an earlier video, but I just want to say again, that way wave manager reads the data at the beginning of every scene, because I don't know how to delete data just at the end of the game, and I'd rather have it read at the beginning of every scene when there's a little bit of a loading period instead of having a memory leak. So that'd be an easy change if I knew how to delete stuff at the end of the game, but I don't. So let's look at the wave manager. Down here is the big if else statement, where it just checks what's the first word, and then then uses the second word as a key. So is the first word spider loud? Then if it's yes, do this. If it's no, do this. And it does that for all the keywords right there. And then it has a function to load the wave, and it takes the int of the wave we are using, and it sets all of the spawners variables to what it has saved for that particular wave. And then all of this is saved in an array of wave data objects, which is in this object class. So it has all these variables right here, and it has these functions to set them and then get them for when it needs them. So a bunch of setter getters is pretty much this whole class. And it also has this default data here, which is if you don't set the data for the wave, it has default data that it falls back to. Then as for deleting things on stage and that the wave can end at any time, that's all done in the game manager. The ship informs the game manager when the wave is ending, and then the game manager tells the wave to end the new level, and the game manager takes care of telling everything else, that the ship has died and to clean up all the objects and do all that. That isn't handled by the wave manager. All the wave manager does is load the data and send it to who needs it. You can see when the ship dies, all it does is tell the spawner that the ship has died and tell the centipede that the ship has died, but it doesn't clean up all the individual critters. The game manager does that. Hi Andre, this video is about the player manager and the player and what that whole system does. So what the player manager pretty much does is manages a list of the players. So it has 3 slots, one for the tractor for player 1 and player 2. It also manages all the functions, and it's basically the interface for everyone to access the players. It also keeps track of the game mode and which player is currently active. That way everyone else who needs to know this and make decisions based on that can ask the player manager, hey, which player is playing, and hey, which game mode are we in? And then for the list of players, the player itself will manage which wave that player is in, how many lives that player has, what the score that player currently has, a Boolean array for what the grid looks like for that player currently, and the offset color for the wave. And that's pretty much all it does. Other people can access which wave we're on, how many lives it has, and it can get the player type and can get the control screen. That's also what it does. It also manages what the control screen for that player is. Hi Andre, this video is over the text and all the classes that come with that. So let's take a look at these classes. So this is the font class that you gave us pretty much. So there's nothing to really mention there. Here is the sprite sheet class. Yeah, once again, there's nothing really to mention here. It's just looking at the sheet and all the stuff that comes with that. Pretty much, once again, the text or the code you gave us. And this is where it gets a little bit more interesting. So we have the glyph class, which is the individual glyphs. So it has the sheet and the position and the cell index. And those are used to form up the sentiglyph strings. So that's a string, or it's a list actually of glyphs. So it's given a string and it's given the position where it needs to be rendered, and the glyphs are pushed back. For the case of scores, since scores get longer, but the last initial stays, or the last letter stays in the same place, so where the 0 first appears, or when you're at 1 point where that 1 appears, that it will always be the 1-digit place. I actually have them printing from all strings printing from the last glyph to the first glyph. So it'll be passed a string like hello, but the 0 and the initial position you're given, that's where the O will be, and then the L, and then the L, then the E, then the H. So they're printed backwards, just get past how numbers are printed. And then glyph strings are used to make up text collections, which are just collections of glyph strings, or are you, yeah. So then how this text collection works is for each scene, there's one text collection. So you tell the text collection that we're either starting 1-player mode, 2-player mode, or attractor mode, and the glyph strings that are in this text collection depend on that. So you use the add string method to add the strings you created to the text collection, and then to draw it, it just goes through the list or the text collection of glyph strings you have, and it calls draw on all of them. So that's management. This is the whole call if there's nothing to update. If there is an update, you can update the player lives here. These are called specifically by player manager. If the player manager notices there's an update in the score, or the score manager, it will call and tell it to update player score 1 or update player score 2.